Hello everyone. Good day to our lecturer Dr. Nur Azizi bin Mardi and to all my fellow classmates. Today we are in Group 7, which is under Section 4, and we will be delivering our group presentations for our course BE 32402, which is numerical methods. So for the next slides, I'm going to introduce about my group members. So let's go. Hello. Before we begin, allow me to introduce our team members, which is the first one consists as members of Nur Iza Afriana binti Muhammad Azri, second one which is Muhammad Haikal bin Aziz, and the third one is Muhammad Azrul Aziz bin Tunizan, and myself, Yuadul Kiraj. So together we will be walking through our project analysis. So for the next slide, we're going to show us about the table of contents. So let's go to the next slides. Hello, welcome back. So basically here is an overview of what we will cover for today's presentation. So we will start with a brief introduction followed by a problem statement. So basically we will explain on how our methodology and our deep dive into our results and discussions, specifically looking at our manual calculation using the trapezoidal rule and Simpson's 1/3 rule, alongside our MATLAB implementations also. So finally we will wrap it up with the conclusions and our reference for this project. So before we go to the further, I would like to inform that for the next slide, it's about the introduction. So I'm going to explain about the background of every single thing. So thank you. Okay, so basically to kick things off, let's look at the background of our study. Okay, basically in electrical engineering, tracking electrical energy consumption is crucial for understanding systems effectively and managing the load demands, which is it's constantly change over time to time. So since the real world power measurement are often collected as it's discrete the data points rather than the continuous functions, so we need to really build the mathematical tools to analyze them. Then that is where numerical integrations method, which is specifically the trapezoidal rule and Simpson's 1/3 rule, come to play, allowing us to accurately estimate the total energy consumption from these discrete power logs to another one. So for the next slide, I'm going to explain about the problem statement on it. Hello everyone, welcome back. So right now for this slide 5, I'm going to explain about the problem statement. So moving to our core problem statement, we are analyzing an electrical load that operates continuously for 6 hours period. So as you can see on the table on the right side here, the power consumptions of the kilowatts recording at hourly interval, giving us 7 discrete data points from 0 hours to 6 hours. So our main objective for this project is to take this discrete data and estimate the total electrical energy consumed over the entire duration using two discrete numerical methods, the trapezoidal rule and the Simpson's 1/3 rule, and be able to compare the performance. So that's all from my side. Thank you.
Okay, next I will explain about the slide of methodology. So this slide show the methodology used in these projects. So in step 1, the power consumption of data of an electrical load was collected every 1 hour over a period for 6 hours. This data we use as the input for the numerical analysis. Next, in the step 2, we use the trapezoidal rule was applied to estimate the total electrical energy that consumption. So this method approximate the area under the power versus time in the graph by dividing it into the series of trapezoid. So next, in the step 3, the same set of data was used to analyze, again using a Simpson one-third rule. This method used parabolic curve to approximate the area under the graph, so which generally provide higher accuracy compared to the trapezoidal rule. So finally, in step 4, all manual calculation we do a manual calculation, then we verify it using a MATLAB programming. The MATLAB result using MATLAB programming, then we compared with the manual calculation to ensure the accuracy and reliability of the numerical method. So that's the methodology that we use in this project. So next, I will explain about step 2 method that we use. That's the trapezoidal rules. So we also calculate the total electrical energy by finding the area under the power graph. The step size is 1 hour because the reading is taken every hour. In this method, the first and the last power value are added normally. So in our calculation here, while all the middle value are multiplied by 2, the first and last value will give 2.7, and the sum of the middle value is 12.1. After the substituting into the trapezoidal formula, the total energy obtained is 13.45 kilowatt hour. This means the appliance or system use 13.45 kilowatt hour of energy over 6 hours.
This is the second method that we use, Simpson's one-third rule. We use Simpson's one-third rule to estimate the total electrical energy. Energy is the integral of power with respect to time. The time interval is 1 hour, so the step size, h, is equal to 1. Then we arrange the power values according to Simpson's formula. The first and the last values are added normally. The odd position values are multiplied by 4, and the even position values are multiplied by 2. After substituting all the values into the formula, we get 13.57 kilowatt hours. This means the total energy consumed during the 6-hour period is 13.57 kilowatt hours.
This MATLAB code is used to calculate the total energy consumption from power data over 6 hours. First, the time data is stored in variable t from 0 to 6 hours. Then, the power data is stored in variable p in kilowatt. The step size h is calculated by subtracting the first time value from the second time value. In this case, the step size is 1 hour. After that, the code calculates energy using the trapezoidal rule. This method estimates the area under the power time graph using trapezium shapes. The result obtained is 30.45 kilowatt hour. Next, the code calculates energy using Simpson one-third rule. This method uses a parabolic approximation, so it is usually more accurate than the trapezoidal rule. The result obtained is 30.57 kilowatt hour. Finally, the fprintf command is used to display both results in the command window with 2 decimal places. The unit kilowatt hour because the power is in kilowatt and the time is in hour. So energy equal power multiplied by time.
For the conclusion, the total electrical energy consumption was successfully estimated using two numerical methods. The first method is trapezoidal rule. The second method is Simpson's one-third rule. So for trapezoidal rule, the results we obtained is 13.45 kilowatt hour. So for Simpson's wanted rule, the result we obtained is 13.57 kilowatt hour. Simpson's wanted rule provided a more accurate estimation due to its higher order approximation.